Overview of dye penetrant test. Welcome to my channel. Please subscribe my channel for more informative videos.
Introduction. Dye penetrant inspection, DPI, also called liquid penetrate inspection, LPI, or penetrant testing, PT, is a widely applied and low-cost inspection method for all non-porous materials, metals, plastics, or ceramics. This method is used to identify following types: discontinuities, cracks, porosity, lapse, seams. Dye penetrant testing process. Dye penetrant testing process is divided into 4 steps. Pre-clean and dry the test surface of the object. Penetrant application. Removal of penetrant. Developer application. Pre-clean and dry the test surface. Cleaning of the surface is very important and critical part because it affects the test result. Contaminants, soil, moisture either inside the discontinuity, or on the part surface, at discontinuity open can affects the test result. As per ASME Sec V Article 6, T642 and T643, following point we have to do for surface preparation. Prior to each liquid penetrant examination, the surface to be examined and all adjacent areas within at least 1 inch. 25 mm, shall be dry and free of all dirt, grease, lint, scale, welding flux, weld spatter, paint, oil. Typical cleaning agents which may be used are detergents, organic solvents, descaling solutions, and paint removers. Degreasing and ultrasonic cleaning methods may also be used. After cleaning, drying of the surfaces to be examined shall be accomplished by normal evaporation or with forced hot or cold air. Penetrant. Liquid penetrant testing is a method that is used to reveal surface breaking flaws, by bleed out, of a colored or fluorescent dye from the flaw. Penetrant means, which have penetratability. Dye penetrant penetrate into discontinuity of specimen by capillary action, which produces contrasting indications against the white developer background. Capillary action is the ability of a liquid to flow in narrow spaces, without the assistance. It occur cause of adhesion and cohesion. Classification of penetrant. Penetrant are 3 types: visible dye penetrant, fluorescent dye penetrant, dual sensitivity penetrant. Each types of penetrant is again classified into 3 groups according to their removal process. Solvent removal penetrant, water washable penetrant, post-emulsifiable penetrant, visible penetrant. This types of penetrant, visible in normal light and containing visible color. Normally red color. The visibility is further enhanced during the liquid penetrant process by application of white developer. Visible penetrant is divided into 2 types. Water washable. Solvent removal. Water washable penetrant. Water washable penetrant is removed by water. The water pressure shall not exceed 50 psi, 350 kPa, and the water temperature shall not exceed 110 degrees Fahrenheit, 43 degrees Celsius. It is inbuilt-in emulsifier, and easily washable in water. Suitable for rough surface or thread. Poor reliability for wide and shallow discontinuity. Water washable penetrant. Applications. Defect location. Open to surface, ideal for large parts, castings, forgings, welds, pressure vessels, tubular goods. Defect examples: cracks, leaks, incomplete weld penetration, incomplete weld fusion, undercutting, slag inclusions, flux inclusions, weld porosity. The flash point of this penetrant is 200 degrees Fahrenheit or 93 degrees Celsius. Applicable temperature for use is 5 degrees Celsius to 52 degrees Celsius. Also store this penetrant at 10 degree to 30 degrees Celsius. Solvent removal penetrant. This type of penetrant is removed by solvent. Main advantage of this type of penetrant is portability and excellent for checking a large part. Method of application. Penetrants can be applied by immersion dip, brush, flow-on, conventional or electrostatic spray. Penetration time and temperature. The generally accepted minimum penetration time is 10 minutes. However, specific process specifications may require longer penetration times. SKLSP1 should be used at temperatures between 5 degrees Celsius and 52 degrees Celsius. Penetrant removal. SKLSP1 excess surface penetrant. Can be removed by either SKCS or SKC, I. Fluorescent penetrant. This types of penetrant is colorless and not visible in normal light. It require ultraviolet or black light to visible the penetrant. This penetrant emits yellowish-green light when exposed to near ultraviolet radiation. Its wavelength is 320 to 400 nanometer. This property is termed fluorescence. Dwell time. Minimum dwell time after penetrant application is 5 minutes, and maximum time is 10 minutes at 10 degrees to 52 degrees Celsius. But for 5 degrees to 10 degrees Celsius, the dwell time will be double. Please see this chart for dwell time. Standard temperature. As a standard technique, the temperature of the penetrant and the surface of the part to be processed shall not be below 40 degrees Fahrenheit 5 degrees Celsius, nor above 125 degrees Fahrenheit 52 degrees Celsius throughout the examination period. Local heating or cooling is permitted provided the part temperature remains in the range of 40 degrees Fahrenheit to 125 degrees Fahrenheit, 5 degrees Celsius to 52 degrees Celsius, during the examination. Contaminant control in penetrant. Nickel base alloys, as per ASME Section 5 Article 6 Appendix 2. The sulfur content shall not exceed 1% by weight. And 4. Austenitic or duplex stainless steel and titanium, as per ASME Section 5 Article 6 Appendix 2. The total halogens content shall not exceed 1% by weight. Developer and its application. Developer increases the intensity, brightness, of fluorescent liquid penetrant, and visible penetrant indications. Developer is highly absorbent, the penetrant is drawn out from the discontinuity by its blotting action. The developer are basically two types. First is dry developer. Second is wet developer. Wet developer are two types. First is aqueous developer and second is non-aqueous developer. Aqueous developer is also divided in two categories. First is water suspension type and second is water soluble type. Dry developer. Dry developer shall be applied only to a dry surface, by a soft brush, hand powder bulb, powder gun, or other means, provided the powder is dusted evenly over the entire surface being examined. Aqueous developer. Aqueous developer may be applied to either a wet or dry surface. It shall be applied by dipping, brushing, spraying, or other means, provided a thin coating is obtained over the entire surface being examined. Drying time may be decreased by using warm air, provided the surface temperature of the part is not raised above 125 degrees Fahrenheit 52 degrees Celsius. Note, blotting is not permitted. Non-aqueous or solvent developer. Non-aqueous developers shall be applied by spraying, except where safety or restricted access precluded. Under such conditions, developer may be applied by brushing. Application method: spray ASME Sector 5 Article 6, T675.2. Removers. Solvent removers have traditionally been petroleum base or chlorinated solvents. Due to this, removers are flammable products. Water itself can be used as a solvent, for water-washable liquid penetrants. Remover applications. Non-destructive testing pre-cleaning. Removing excess surface penetrant. Post-inspection cleaning. When chlorinated solvents are undesirable, or prohibited. To remove excess surface penetrant, apply SKC1 to a cloth, wipe test surface and repeat as needed. Remember, do not spray SKC1 directly on the part, because penetrant indications may be removed. Now it's time to practical demonstration.
This method involves three materials, namely cleaner, penetrant and developer. The process is explained in steps here. Step 1. Cleaning. First, the surface to be tested is cleaned thoroughly with ordinary waste cloth. Then, clean the surface with a waste cloth sprayed with cleaner. Step 2. Penetrant application. Apply the penetrant gently over the surface to be inspected. Allow the penetrant belt time as per the established standard norms to make the penetrant to completely penetrate inside the sieve. Step 3. Removal of excess penetrant. Clean the excess penetrant over the surface using ordinary waste cloth. Again, clean the surface with the cleaner applied cloth. Step 4. Developer application. Gently apply the developer over the clean surface. Allow the belt time for the developer as per the established standard norms. Step 5. Inspection and evaluation. Now, inspect the surface for any defects which will be in the color of penetrant. Evaluate the defects, if any, in the acceptable values and take decisions to accept, rework or reject. Here, the flaw is established in this part by this method.
Types of defects. After practical demonstration, it's time to inspection of DPT. Penetrant indication are classified into three groups. First is relevant indication, second is non-relevant indication. Third is false indication. Relevant indication. Relevant indications are caused by discontinuities in the surface of the part. It is important that all relevant indication are discontinuities, but every discontinuity is not relevant indication. Relevant indications are divided into continuous line indication, intermittent line indications and round or dot indications. Continuous relevant indications are cracks, seams, cold shuts and forging laps. Intermittent line indications are also caused by continuous indications. Rounded indications are caused by porosity, pinhole, a porous surface or a coarse grain structure. Some example of relevant indications. Non-relevant indication. Non-relevant indications are caused by surface irregularities or part configuration. Such kind of indication not directly affect the serviceability of part. Non-relevant indication also found in welded part where the surface condition is rough. Example of non-relevant indication. False indication. False indication are caused by following reasons: poor processing conditions, lack of cleanliness, lint of clothes. False indications are prevented by good process control. Safety during test. DPT testing kit, dye, developer, remover, are extremely flammable, and all are pressurized containers, so keep away all container from heat and damage. Don't spray developer and remover in open flame, cause fire. Use dust mask during test to avoid breathing this cause lugs diseases. Use rubber hand gloves, to avoid contact of penetrant material, it causes skin irritation, if contact for long time. Use safety goggles, during test to avoid direct spray on eyes. Always perform this test, in open space and ventilated area. Use proper ventilation, in confined space. 24-volt hand lamp, or flame-proof light is highly recommended during test, in confined space. Dispose all used material in proper place. Thank you for watching. Please like, share and comment. And subscribe my channel.